In this video, we're going to look at dividing polynomials by synthetic division. Synthetic division is a way that you can divide one polynomial by another as long as you have certain criteria that are met. If those criteria are not met, an alternative to synthetic division is long division for polynomials. That's also talked about in this section, but it's not something that we cover in college algebra. It is covered in beginning and intermediate algebra. So let's take a look at the condition for being able to use synthetic division. Now here's some terminology that we're going to be using as we talk about these division problems. When you do a division problem, you have a dividend, okay, that's divided by what's called the divisor. Your dividend is what's divided into, your divisor is what's divided by, okay? So for example, if you were to have something like 16 divided by 4. The dividend here is 16. The divisor is 4. Okay, and there are other forms for writing a division problem. You may see it written as a fraction with the dividend on top, divisor on the bottom, or you may see it written with the division symbol. Okay, that's going to be equal to a quotient plus a remainder. Okay. So if we do the division here, the quotient there would be 4, because 16 divided by 4 is 4. And then in this instance, 4 goes into 16 evenly, so the remainder is 0. To be able to use synthetic division, you have to have a divisor that's in the form x minus c. The x has to have a coefficient of positive 1, and it cannot have an exponent of anything besides 1. Two additional conditions that are not unique to synthetic division, but must be done anytime you're doing polynomial division, long division, or synthetic form. The dividend and divisor must be in descending order of powers, and if the divisor is missing terms, you must use 0 as a placeholder. And I'll show you what it means to be missing terms in just a second when we start a problem. Now, what I want us to look at is the form that we need to use when we create the synthetic division. Okay? So what you'll want to do is you take c out of the x minus c expression. Now, since you're given x minus c as a little binomial, the c value will actually be the opposite of the c value, the constant value that you have inside that expression. Okay? You will take c, and it stays over to one side. And there are a couple of different ways that you can draw the little box, or whatever you want to call it. Across from the c, across the very top of the box, you're going to put the coefficients and constant of the dividend. So here we have the divisor, okay, that's the c part right here, and then we have a representation of the dividend with the coefficients and constant, the numbers only. We don't use the x's, we don't use the degrees, we use only the coefficients and the constant, okay? And what's going to happen is we're going to follow the synthetic division process, and what you'll wind up with are the coefficients, let me abbreviate there, and constant of the quotient. And then the very last number that we get over here at the end will be the remainder. Okay? And if we write that down as a as the answer, where we'll actually have quotient plus remainder term. Okay? The remainder term will actually be the remainder divided by the divisor. Alright, so let's give this a try. Let's say that we want to divide x squared plus 9x cubed minus 6 plus 4x to the fourth. Okay, I want to divide that by x minus 2. Okay, so the first thing that I want to do is I want to pull the c value out of that divisor. Okay, If we compare that to x minus c, you want to write down what c is equal to. Okay? So if you pull the constant out of that x minus c form, your c value is positive 2. You take the opposite. Okay? We had a negative, now we have a positive. So c will be equal to 2. The next thing that I want to do is set this up the way it needs to be set up. It needs to be in descending order, and if I have any terms missing, I will have to put a placeholder in for those terms. So I'm going to start out by rewriting my division problem a little bit, just so that I've got things in the right order and I can tell if I'm missing any terms. So my divisor is x minus c. I'm not missing any terms there, and it is in descending order, so that's not a problem. My dividend just a little bit here. My dividend, my highest degree term is this 4x to the 4th, so that'll be the first term. Okay, it has to be in descending order of powers, so what that means is that your largest power comes first, and then your next to largest, and then your next down, and then so on and so forth, okay? So my dividend will start with 4x to the 4th. Second term is the x cubed. Then we go down to the x squared term. And then we take a look through here, and we're missing an x term. So we'll put a placeholder in where that term would be. And then we finish up with our 0th degree term, our last term, our constant. All right, so now we have our c value right here, and we have our dividend in descending order. So let's create the synthetic division. Okay, so to set it up, we put the 2 here, and then we list out the coefficients of the polynomial. That's going to be the 4, the 9, a 1 from the x squared term, a 0 from the term that's missing, and then a negative 6 at the end. So 4, 9, be sure you leave enough space between them so that you know that they're not connected in the same number. Okay. Now the pattern goes like this. The first thing that we always do with the very first term is you drop that coefficient straight down. You don't do anything to it, you just drop it, okay? That is because we're dividing by x minus c, and x doesn't have a coefficient that's anything other than positive 1, so that first term is always going to be the same. Now, here's the part that's going to repeat from term to term all the way till you get to the end, the very last term. You multiply the c value, which is right here. You multiply that times the number that you drop down here, and you're going to write that number under the next term. Okay, so let's do that. 2 times 4 is 8, and I'm going to put that 8 right there under the 9. The next thing that you're going to do in the process is combine these terms straight down. Okay, so 9 plus 8, they're both positive. 9 plus 8 gives me 17. Then we just continue on from there. I'm going to take 2 again, multiply it times 17 this time. That's 34. Put that under the 1. I didn't give myself quite enough space, did I? Kind of run them together. So I'm going to have 1 plus 34. That gives you 35. 2 times 35, right? That's going to go right here. So 2 times 35 is 70. Combine that with a 0 because that's our missing term, right? And then 2 times 70 is 140. That's our last one. Okay, so one last step. We do minus 6, or negative 6, plus 140. Opposite signs, we subtract, take the sign of the larger. That's 134 that we'll get from that. That term is the remainder. The rest of these terms are the coefficients of our quotient. Okay, what that means is we will put the x's back in to get the polynomial that's the quotient here. Now, when you do synthetic division, one term through synthetic division will knock a degree off the polynomial. So if your original degree was 5, then your quotient's degree will be 4. If your original equation's degree was 10, then your quotient's degree would be 9, and so forth, okay? If you forget that, what you can do is start writing the quotient from the last number instead of the first, and then you just pick up your x's as you go. So let's see what we've got here. I started with a 4th degree polynomial, so this one's a cubic, 3rd degree. 4x cubed plus 17x squared plus 35x plus 70. Notice we get every term down to the constant, okay? And then we have one more thing to write. The remainder term is the remainder over the divisor. My divisor was, look up and look, x minus 2. And so that's what sits under there, okay? And when you're just doing regular synthetic division like this, that's the form you want to write the answer in. As we begin to use the synthetic division to do other things, sometimes the quotient will be important to us, sometimes the remainder will be important to us, and sometimes it's both. So you really have to focus on what it is exactly you're working with that particular type of problem in order to know which piece you need, okay? But for the problems that just say divide synthetically, this is the answer that you want to give. You want the quotient and then the remainder term at the end.